This is my calculator tutorial for the second exam review. So these are all the techniques you're going to need to be able to do, and I'll do this one with the Ti-84 plus CE calculator. Any of the Ti-84s or Ti-83s will work very similarly to this. If you have either a Ti-83 or an older Ti-84, some of the functions may look a little different, but the button presses and stuff should be very similar. So the first thing is for matrices. There's a few things we will need to have you be able to do. So this is not necessarily going to be a working through the review, but I will use the review to highlight these different things that we kind of need you to be able to do. So first we're going to be able to enter a matrix, which is using the edit. Also managing how to clear out matrices, so I'll show you that. We're then going to go with the basic operations. So we're going to use this one here, basic ops. Then we'll work through a number of these for both of those, and then I'll use some of these also for some of the specialized things we're going to have you do. Actually, let me get back to ops. We're going to have to add, subtract, multiply, and then also do transforms, which is just switching the rows and the columns, but I'll show you how to do that. And then along with that, how to take an inverse. That's again kind of just doing an operation, so we'll take an inverse this way, transform, and I believe that'll do most of the stuff. And finally, actually not finally, but how to find the determinant. So we'll do all of these sort of with this first part here. Then we're going to show methods for solving systems, and we'll break that down into reduced row echelon form, and the other one we'll use is the matrix inversion, taking the inverting a matrix inversion, not transform, an inversion. So we'll use those two methods, and then Kramer's rule we're not going to deal with directly. That involves the determinant, and it's a way of solving, but we get the same solutions with either reduced row echelon form or the inverse inversion method. So these two will work. Kramer's rule gets us the same results as either of these two, so it's just more complicated and not really helpful. It's an older way. Now that we have the technology, we'll use these two. So again, this is a focus on technology to make all this happen. And then I will also move on to the probabilities and such, but maybe I'll do that in two separate videos. We'll see. So let me just kind of clear this out. That's kind of what we're going to go. So first of all, maintenance. Second matrix. This is going to be the key you're going to use for all of these operations. We've got the names, so this is where we come when we want to use a matrix. We have the math if we arrow over, which gives us the things we're going to do. We're going to talk about the determinant here. We're going to use the transform. We're not going to use any of these, but we will use reduced row echelon form. Some of you were using REF. That's not good enough. That doesn't get you far enough. You want to use RREF. Okay, so that's a big deal. There's probably some other things, but these are ways you could sort of manually get to there, but we're not going to need to do that. And then we need to be able to edit matrices, and this is where we actually enter them. Before I get there, let me, I've got B, C, this is the I matrix, and E from the question 1. A is not correct, but, so let me show you how you will get rid of A. I want to get rid of A. So, okay, go to memory. So second, memory. And then what I want to do is I want to do memory management. So that's the one thing you have to remember. And then after that, it's pretty easy. Oh, we want to work with matrices, the matrix. And it shows me all the matrix. And to get rid of A, all I have to do is hit the delete button. And now A has been cleared. It's been deleted. These other ones I'm not going to delete. Again, I could, but this is how you clear out matrices after you really are done with them. So I go back, not to math. That's what I keep hitting. I need to go down to matrix. And I'm going to edit A. Okay, so this is how we enter a matrix. You first have to tell the dimensions. Remember, the dimensions are how many rows by how many columns. So this one is a 3 by 2. And you see it right away. If you get it backwards, that's the nice part of the technology. If I would have put a 2 by 3, because I reversed the dimensions, I would have seen, oh, that's not the right one. Then to enter, we just start entering our numbers. So -2, I have to use this negative down here, not the subtraction button. I get some kind of error if I do. 0, we enter this way, and we just keep on, we keep hitting the enter. We enter and move. It moves for us, which is kind of nice. Okay, so I've got the A matrix all entered in. I've already done this for the B, C, the I, and the E. I did the same thing. I entered those matrices, as you can see here. So B is a 2 by 3, 2 by 3. C is a 2 by 2. D is a 2 by 2, and that's what we call the identity matrix. And then E is a 3 by 3 matrix. So now we can just work through these with the technology. Now, a point I will make, it's a little different. So when I go through to work these, I will actually work out anything with the B, because B has this X. We can't put that in there. So what I did is I replaced that. Let's not use it. Let's go over to edit. I'll show you. Oops. Go over to edit, down to B. I'll show you what I did with B. I put in a 2 instead of an X. You cannot put an X in here and have your calculator handle it. That's something that needs to be done manually. That's why down here they have some of these matrices have some variables in there. It forces you to have to do it by hand. So I will do those when I do the solution videos. But for now, I've just replaced the X with a 2. So maybe I should go ahead and mark that down. That X has been replaced with a 2. Okay, so I'm going to get different answers whenever I use the B than is down below. But again, the purpose of this particular video is to focus on how to use the calculator. Okay, so what's my next step? So we now know how to enter matrices. Hopefully we've already got that. Basic operations. So let's take what should we do first? I guess we could just do these in order. We'll see. Remember, when you're adding or subtracting, as down here, matrices, they have to be the same size. So you could not add A and B, right? Because they're different sizes. They have to be identical, exactly the same size. We could add C and I, which I've got as my D. But those are really the only 2 matrices we're able to add. Now, if we do some other transformations, we might be able to add them, maybe not. If it can't be done, the nice thing is when we put these in the calculator, it'll give us some sort of a dimension error that it can't be done because the shapes are not the same. Let me just start by taking, I'll add one, I'll do C plus I. So I'm going to do C plus I. And what you'll see is the calculator will take each item and add them together, term by term. So this will become 1, this will become 1, this place here will become 1, and -1 plus 1 will become 0. So we should get, I mean, we could do that manually, 1, 1, 1, 0. But I'll just show you using the calculator how that can happen. So we go second, quit. That gets us back to the main calculation screen. At least that's how I do it. Might be another way, but From the calculator screen, I just need to find, this is where I'm going to use the name of the matrix. So I use C plus matrix, oops, always go there, matrix D. So I come down to D, I want to use D. I add them together, hit enter, and notice we've got 1, 1, 1, 0. So it adds. If we wanted to subtract, we could do the same thing. We pull up our matrix, let's do C minus matrix D, and it'll take all the values from D and subtract them from C, and we get a different matrix, right? So that's subtracting them all. But you can add or subtract matrices. And again, I'll just show you, if we were to take matrix A and try to add or subtract, it doesn't really matter, so we'll just go with addition. Matrix B, we're going to get this error statement, dimension mismatch, means it's impossible, not possible to do that because they're not the right shape. So that's addition, subtraction. Multiplying two matrices becomes the same, so I'm going to jump and take a look at both C and D. Now A times B is going to be different. We're going to see them B times A. Can we do this? Now, when multiplying matrices, and again, we'll focus on, you can't just do A next to B. This we'll show you. But when you multiply matrices, remember the dimension, the middle dimensions have to be the same. So A is a 3 by 2. A is a 3 by 2, and B is a 2 by 3. So the 2's will basically cancel out. The resulting matrix will be a 3 by 3 matrix, and this can be done. If we switch the order of B times A, we'll see we'll have it, B is a 2 by 3, A is a 3 by 2. It can be done, but the resulting answer is going to be a 2 by 2 matrix. And I guess I should, so when we multiply these two, we get a 3 by 3. So we get different things. Calculator will handle all of this for us. You will get some practice doing it by hand as well when you do that X thing in there. So let's just look at these two, C and D. How do I do it with the calculator? I simply come here, second, quit. Let me just clear all this out. I'm going to take A times B, so second matrix. I'm going to use A. I'm going to multiply it times B. Now, usually when you write things together, because you think there's this bracket, I could put matrix B here. It's not going to work, I'll tell you, but I just want to show you. Oh, maybe it did work. Let's see if that's the same thing we get when we go to, I was expecting it not to work because I know with some of you, and maybe it's the older version, you actually have to put this in. So I'm not sure, I didn't expect it to work. We should get the same answer if this is correct, and we do. So at least in my version of the software, you can enter them side by side and you're fine. But I believe we tried this with some older Ti-84 software, operating systems. If you have an older software or operating system, writing them next to each other may not actually get you multiplication. Sometimes, I don't know, I can't remember if it gives you an error key or something, but know your calculator, I guess, is the key here. Okay, so we can multiply, and I'll just show you that if we switch the order, we actually get a different result, right? Because we put B times A, and I'll just do this to be on the safe side. Again, it doesn't hurt, it gives us the same thing, but some of us can do it without. Notice we get a 2 by 2. So the multiplication has happened differently. And again, go through the process that we talked about in class of how to do it by hand. But I want you, again, we're focusing on the technology side to be able to use the calculator. Okay, so that's C and D. Let's come with some of these more complicated ones. A transform. That's so we're looking at A here. Specifically, this transform. That's going to switch the rows and columns. So this will become a 2 by 3. This is a 3 by 3. So we will actually we still might not be able to add them together. Let's see, 2 times that. Yeah, we remember to be, oh wait, we're adding to B, sorry. Yeah, if we transform this A, it's going to be a 2 by 3, which is a 2 by 3. So remember, they have to be the same shape to add. So A plus B will be able to happen as long as I take this transform. If I don't transform it, like over here, we're going to see we won't be able to, B is not going to be possible to be done. But something very similar, A is possible. Now what's happening here is there is a scalar multiplication. This 2 is going to multiply by everything in the A transform. The 3 is going to multiply by everything in the B transform. Okay, but again, technology, how do we check our answers, or how do we get there? We're going to use these matrices. So I've got 2 times A, so I'll put in my 2. Maybe this is the place where we need to do the times. I'm not sure. I'm going to go ahead and just be safe, and every time I'm multiplying with matrices, I'm going to use the multiply key. We're going to call it matrix A. We're going to use it by using its name, but I want to use the transform of A, not just A. So then I go back to matrix, over to math, and I come down to this little feature which will take the transform. Again, that just switches the rows and columns. And then I'm going to add 3 times matrix B. Here's matrix B. And let's, again, if it can't be done, it'll tell me, but I'm pretty sure this can be done, and it gives me the answer. Okay. Now again, this won't match the answers at the end because I've changed B from what was originally here, but this will be the answer to the matrices I have listed. I'll do one more. I'll do the one next to it, and I'll show you this one can't be done because A and B are not the same shape without one of them being transformed. Okay, so again, it's not too hard. -2. Pull up the matrix A, and this is again something. If you're in a system where you're using matrices, this would be how you would go about doing it, especially if the matrices are fairly large. And again, we got our dimension mismatch because they're not the right shape. We could have anticipated here, but this is good verification. So let's see, E, again, we can do all of this if it's possible. And again, we just go second quit. We can take 2. And again, this only works when there's all numbers. If there's a variable in the matrix, then that's sort of a way to make it happen. They're forcing it to happen by hand. We want to take the transform. Come over here, take the transform. And then we want to multiply that. Oops, I didn't. I'll show you a little trick here. I want to put the multiplication sign here. I can't remember. It might work on this one, it might not. But if I want it, I go in. INS is for insert, so second insert. Now I can just go, oop, there it is. I don't have to rewrite the whole thing. And then I want to put multiply times C. So I call it matrix C. And then I'm going to subtract, not the minus, so be careful here. This is subtracting 4 times the matrix A. And let's just do this. Okay, if I transform B, it's now going to be a 3 by 2. I'm multiplying a 2 by 2. So I'm going to end up with a 3 by 2. So then I'll be able to add it to A. It should work. Okay, and this will verify, yes indeed, it does work, and it gives me the answer of what happens after all of it. Notice it just takes care of everything. Okay, with that in mind, how do I find the determinant? So a 2 by 2 matrix is not too bad. You cross multiply and subtract the results, but we can just also use the determinant key. So matrix, I'm going to pull up, actually first thing you have to do is come over here. DET is the determinant. I want to get the determinant of C. I just do determinant of C. and it's the number -1. A determinant comes up with a single answer to a matrix. I can take the determinant of E. They have to be square matrices, so only these 2 by 2 can be done. The E can be done because it's a 3 by 3. You cannot get the determinant of A or B. If you try it, it just won't work, and it'll give you an error code. Let's just show you that. Well, let's not spend the time. I want to keep moving forward, but if you want to do that, I think dimension will tell you the dimensions of a matrix. So there's some things that you could play around with here, but these I'm highlighting the things that you really will need to be able to use. So I can find it. And again, the method for finding a 3 by 3 matrix, a determinant, is really a mess. Okay, there's a lot of stuff, and then if you go to a 4 by 4, it's just way out of control. But the calculator can do all those things. It gives you this, and again, the only reason we really need the determinant is if we were going to use Kramer's rule to solve a system of equations, but we have other methods we're going to use. And I think it's time right now, let me check my notes here, to get to those other methods. So we've done the transform, which is basically just a 90-degree rotation. It will handle it. So now there's just really 2 items that we need to talk about doing, and that's getting it in reduced row echelon form. So let me get it to there. What I'm going to do for that is this Gauss-Jordan row reduction. So let's choose one of these. I'm going to go ahead and use B. It's the first thing we need to do is there, and again, we're going to get the same answers for B using this method as if we use the method that is matrix inversion and determinants. So we'll use both methods, and we'll see we'll get the same answer. And then we could do the same thing. It'll give us the answer for Kramer's rule. We won't actually use Kramer's rule. The main thing is we are given something like this, these systems of equations. We need to turn them into a matrix. So for Gauss-Jordan reduced row echelon form, we take the coefficients 5, 1, and 6, and we make that the first row, 5, 1, and 6. And then we've got 1, -1, -2. And then we have 3, 3, 10. So that's going to be our matrix that we will enter. Remember, the columns, these are really x values, these are y values, and these are, I guess, just call them answers. They're the numbers on the other side. This is an augmented matrix, but we will enter this, and let's say, I guess we can, while we're at it, we could just use a new matrix, right? We'll go down to the F matrix. Actually, we don't have to go there. We have to come over to edit, go down to F. We're putting in a 3 by 3, 3 by 3, and we'll see the methods are each a little different how we go about this, but we'll enter 5, 1, 6, 1, -1, -2, 3, 3, 10. Enter, sorry. And so then to get it into reduced row echelon form, we just remember we're dealing with matrix F. We quit. Let me clear off here. We just go down to second matrix. We go over to math, and we just have to remember to arrow down here to reduce row echelon form. Some of you have been using REF. That won't work. It doesn't give it, it's only partially reduced. It's in row echelon form, but not reduced row echelon. We want to use this one. Okay, and then we put the matrix in there that we're wanting to find, which is F. We call it up by the name, and then we hit enter. And this is reduced row echelon form. This says 1x equals 0.666, 1y equals 2.667. I forgot to do one last thing, and let me just show you. I forgot to put the fraction thing in here, so I'm going to pull it back up. I go arrow up, pull it back, and then I remember, if I go math and fraction, it will give me my answers in fractions, 2/3 and 8/3. Now that does match the answer. And typically we can enter these as it, because they really are a point, they're coordinates, right? 2/3 is x and 8/3 is y. So we can list this as a ordered pair, I think is how they have the answer. Well, I know it's how, because I checked earlier. And 8/3. Okay, those are the solutions. X is 2/3, y is. So it's solved the system of equations. We know it solved this last row of 0 equals 0 is true. It just shows that this was sort of redundant. It wasn't needed. It went through a process and it got us the ones here. And this, you could do it by hand as well, but it's tedious and it's error prone. It's so easy to forget a negative or do something like that. Okay. So that's one method, reduce row echelon form. It starts with this augmented matrix, and we just do that and we're able to do it. Okay. Second method to get the same thing, I'm going to use the same one because I want to see that we do get the same answers. Actually, what I'm going to do though, see if you multiply this by, so which one? 3, 3, 10. This is probably a multiple of one of these, maybe this one. But so one of these equations, we could drop it off. I changed my mind. The reason is when we use the other method, we're going to take matrix A times the variable matrix, and the variable matrix is just x and y. It's really just, so I need something that's only two rows, because this is 2 rows, or 2, yeah, actually ends up being 2 columns. And anyway, we'll keep moving. One of these should be able to be redundant, because you only need 2 equations and 2 unknowns. Maybe these 2, I don't know. So I'm going to move forward. Well, let's come back. Let's do this one, I guess, with the other method. This will be easier to set up. So this one we want to set up, well, let me clear this out. Let's go down to this using the matrix inversion and determinants. So evaluate each determinant. Again, I showed you how you do it. They're square matrices. You just enter them, use the determinant. Okay. These first ones, there's a method that is fairly easy to use, so you could double check that. This one, it's not easy to use. It's a mess. Don't even give it a try. Just use the technology. Let's see. Let's come to here, matrix inversion method. So let's choose one of these. Now this could work because it's an XYZ, so it's 3, but let's just go with B. Okay. So we use this one, and I'll just show you the other method. We use the calculator slightly differently because we're going to set it up differently, and then that'll be good. So what we do is we break this into 3 matrices. We break it into sort of the coefficient matrix times the variable matrix, which we just label X, equals the answer matrix, these numbers over here. Okay, and then the way of solving it is we're going to take the inverse of A, which cancels out on this side, so we're going to get that this variable matrix is going to be equal to the inverse of A times B. Okay, so this is what we're going to enter into the calculator once we get A and B set up. And so the way we set up A, I'll come over here. A is going to be the coefficient matrix, so that's 3, 3, 6, 30. So it's a 2 by 2 matrix. The matrix X is going to be A and B, and we don't really set it up, but we just are sort of using it that we're going to get the answers this way, so we don't really have to enter this one. And the matrix B, I guess I'll call it big B, is going to be the 2 by 1 matrix of just the answers. It's 180 and 600. So I'm going to enter A and I'm going to enter B, and in my calculator I'm going to enter A inverse times B. Okay. So let's go ahead and clear out some of these from memory. So I'm going to, because sometimes it's easier to use the letters that they give us. We'll go to 5, and I'm going to delete A and B. And while I'm at it, let's just delete them all. I don't think I need to use them again. Then I go second matrix to go back. I'm going to edit A, and that's going to be my 2 by 2 matrix. 3, 3, 6, and 30. And I'll also do this one with reduced row echelon form just to see that we get the same answer, but we enter them differently. Okay, so I go back second matrix, we'll enter matrix B. Oops, matrix, go over to edit, matrix B. Matrix B is a 2 by 1, and I enter the 180, 600. And while I'm here entering, I'm just going to go ahead and go to matrix. I'm going to put in a matrix C, which will be the augmented matrix, which is going to be basically A with the column from B added in. And then we'll do reduced row echelon form on that. So I'm going to put in a 2 by 3 matrix. This is the augmented matrix, coefficients, and then including the answers. So just to kind of show you that this one's actually my favorite method, but we can do the other one. They both work. Because this, you just enter one matrix and we do reduced row echelon form, we'll get the same answer. Okay, so I'm going to go to quit. Again, what you need to remember is sort of by hand, we're going to do this thing so the variables are equal to the inverse of A times B. And we'll get a 2 by 1 matrix, and the first one is going to be A and the second one's going to be B. So sometimes it's that's the nice part of it. It's the answer's very clear. So we go to matrix. We're going to use A, so I pull that up. We're going to take its inverse, which is this x to the minus 1, and then we're going to multiply that times matrix B. It's all this setup. But once you have it set up, it's very simple sort of algebra. And we get the answer that A would be 50, B would be 10. So these variables. Okay, so this would be our answer. Now watch, we're going to do the reduced row echelon form on C matrix, and we're going to get the same. Let's just do it. Second matrix. I need to first pull up the feature, or the tool of reduced row echelon form, and then I need to pull up the matrix C where I put the augmented matrix, and then I'm going to hit enter, and it's A equals 50, B equals 10. So it's really a personal choice whether you want to use the reduced row echelon form. It's kind of, I like it, you enter one matrix, you get it. This other one is a little bit more algebraic, and then we just have our answers here for the variables A, little a, and little b. So the same thing will work. The Kramer's rule gives us the same thing. So I just didn't see the need to teach 3 different methods to get to the same sort of solutions. I think 2 is enough. And these 2 have a nice sort of difference in their mathematical quality. Kramer's rule only works well for a if we have a square matrix and a 2 by 2, it gets really bad when we get anything more. So anyway, if we have more, let's use one of these methods. So that's pretty much doing matrices with the Ti-84. I'm going to stop this, take a deep breath, a little rest, and then we'll come back and we'll take a look at probability.